Welcome to my second video about rocket orbit and missile analysis system called ROMAS. In this video I'm going to be talking about some potential ways to have fun with the programs. As always, if you are interested, you may contact us at rocketscienceprograms.com. In my first video called ROMAS Rocket Man, I showed the objective of building a high-fidelity, fast-running set of aerospace programs exclusively for the Mac. My target audience was for aerospace engineering students, future rocket scientists, and even aerospace engineers. It was a more serious technical introduction. In this video, I'm going to introduce some ways to have some fun with design competitions. You can also use the same ideas for class assignments, and that would be most likely high school and definitely above. Cases are limited only by the imagination of the instructors or the game moderators. More specifically, challenging than any video games I've seen. The basic question is who can design the best? I'm going to cover examples from the 4 prime ROMAS programs: Rocket 2, Orbit Bench, ASAT Bench, and Missile Bench. As you would recall, Rocket 2 is a high-fidelity point mass modeling program that uses a rotating spherical Earth and provides launch vehicle performance simulation and orbit determination. Some of the possible games or assignments might include, number 1, designing a launch vehicle for the lowest liftoff weight. Given the required payload mass, say a 3-stage vehicle and a specific parking orbit. Must use certain data to be consistent, that being launch point, azimuth, atmospheric and coefficient of drag data, Earth data, and those things to level the playing field, make sure everyone's using the same input. May allow the user to select from a certain number of rocket engine performance options, solid profile, or a liquid stage fuel, the structure mass, and ratios of structured mass to fuel mass to allow for increasing one as you increase the other. Might also examine the results and preliminary designs in the utility program and then finalize and prove the design using Rocket 2. A variation or option on the above is to design a launch vehicle with the lowest cost. The same as above, but it's even more complicated. You would add cost parameters for each of the launch vehicle elements in the design and then come up with the lowest weight and lowest cost launch vehicle. The second program is Orbit Bench. It provides orbits, ground tracks, and identifies satellite sensor coverage of selected areas of interest, and then turns around and allows you to consider the detectability of these satellites by ground-based radar NC cube sites. About some of the game class assignments, let's consider determining the optimum orbit to provide coverage. That coverage is of selected areas of interest. You would be given a satellite sensor footprint and then provide coverage of a list of areas of interest and how much time the satellite had to provide that coverage. A second option would be to design a radar detection system to provide the best detection coverage. You would be given an orbit, limited number of radars with restrictions on possible locations, and given basic radar design parameters as min and max range, start and stop azimuth, and min and max elevation coverage. The end result would be to use the metrics generated by the programs to determine which is the best. The third program is the ASAT Bench. This provides tools to understand anti-satellite engagements between target satellite orbits and attacker satellite orbits. Some of the possibilities for a game or a class assignment: number 1 would be to determine the best attacker orbit. You would be provided with a target orbit or constellation of orbits. You would be given an attacker weapon kill range and the time limit for the engagements. The objective would be to determine the attacker orbit that gives the maximum number of engagement opportunities. Another example would be changing any of these variables because there's an unlimited number of possible cases in the area of target orbits, attacker kill ranges, and the time limit for engagements. The last program is the Missile Bench program. It provides tools to understand ballistic missile trajectories, the coverage of those trajectories by ground-based radars, geostationary warning satellites, or anti-ballistic missile defense systems. Some of the game or class assignment opportunities. Number one, design the best radar surveillance system. You would be given a set of threat trajectories, a number of radars that would be allowed with specific radar performance and maybe some location limitations. The objective would be to determine the optimum system with the best detection coverage of detections as well as warning times. Another example would be to design the best ABM system. You'd be given a set of threat trajectories, again, with a budget for interceptors and radars. Given the kill volume for the interceptors, and that would be defined the same way as you would define a radar coverage volume, and then optimize the effectiveness of your ABM system against that set of threat trajectories. That concludes the ways to have some fun or provide classroom assignments for the primary 4 programs in ROMAS. If you've missed my first YouTube video, you can find it under the name of ROMAS Rocket Man. If you want more information about the ROMAS programs, you can visit our website at rocketscienceprograms.com, or you can email me at thedeveloper.romas@gmail.com. Thank you for watching.